You are probably led to believe that calculus is something that takes years to study and only truly gifted students ever master it. But what if that wasn't true? What if I was to tell you that calculus is based on an idea so simple that you probably think about it many times a day without even realizing it? And the best part is you don't need advanced mathematics to understand it. No complicated formulas, no fancy equations, just one basic concept that makes it all possible. So buckle up, because at the end of this video, you will finally understand what makes calculus possible and why limits are right at the center of it all. Let's start with a simple thought experiment. Imagine you owe the bank $100. You make a deal with the bank to pay off half of the remaining balance every single day. Today, you pay off what you owe. So you pay $50. Now you owe the bank $50. Tomorrow, you pay off half of what you owe. So that's $25. Now you owe $25. And so forth, every day, $12.50, $6.25, $3, 125, and so on and so on. Each payment makes the remaining debt smaller and smaller and smaller. But notice something strange. No matter how many times you do this, there's always a tiny amount left. You never actually reach zero. Yet, everybody can see what's happening. The debt is getting closer and closer to zero. That's the key idea behind the limits. A limit isn't about arriving, it's about approaching. The mistake is believing that getting infinitesimally close and arriving are two completely different ideas. So let's look at the numbers: 1 half, 3 over 4, 7 over 8, 15 over 16, 31 over 32, 63 over 64. What do you notice? They're getting closer and closer to 1. But no matter how close two numbers are to each other, there's always a number between them. In fact, we can make them as close to 1 as we possibly want. No matter how demanding you are, eventually the sequence gets that close. And that's the key idea behind the limits. A limit isn't about reaching a value, it's about getting arbitrarily close to that value. At first, that sounds like a mathematical game. So, what's the limit? A limit simply is a value something approaches as it gets closer and closer to the target. That's it. No magic. It's not complicated. Just approaching. And once mathematicians realized they could describe approaching with perfect precision, calculus was born. So let's now see how limits actually work. Suppose you have a town with a main street that runs east to west and a first street that runs north to south. Alice travels on the main street from the east, while Bob travels on the main street from the west. They both approach the first street from different directions. As Alice gets closer and closer to the first street, she gets closer and closer to a coffee shop beside the intersection. As Bob gets closer and closer to the first street, he notices he's getting closer and closer to the supermarket on the other side. So let's think of f of x as being the distance away from the center of the main street along the north-south direction. Alice will be approaching the first street as she's driving along the main street from the left, denoted by 1 minus. The limit then identifies the exact position on the first street that she is approaching. Similarly, Bob will be approaching the first street as he's driving along the main street from the right, denoted by 1 plus. The limit then identifies the exact position along the first street that he is approaching. In this case, Alice will be approaching the coffee shop and Bob will be approaching the supermarket. Now, although we have no problem telling that both Bob and Alice approach specific locations, the destinations that they're approaching are different from each other. Now, is that a problem? So, this is when math gets a little bit strange because it requires an ironclad definition of what exactly a limit is. Despite the fact that both Alice and Bob are approaching a well defined location, since those two locations are different, mathematically, the limit does not exist. In other words, the only way we can make a statement that a limit actually exists is if both Alice and Bob are approaching exactly the same location. And that is fundamentally what makes calculus work, what allows calculus to be used in sciences and engineering.